square root of 19 over 5. Here's another example. Write the equation of the ellipse with an eccentricity of 1/2 and vertices of -4, 0, and 4, 0. Again, this second piece of information of where the vertices are is actually very important. Remember, the vertices are on the major axis. So by looking at the fact that the vertices go to -4 and 4, that tells us that our major axis is also going left and right along the axis, just like the vertices. So it means that your major axis is your x-axis. It also tells you that you're going left and right 4, which means that your radius for your major axis is also 4. That means your A is 4. Remember, A is the radius of the major axis, whatever it is. Okay, so we have the A, excuse me, that we have that A is 4. So we can plug that into our formula. Remember, our formula for eccentricity is E equals C over A. So that's our formula, E equals C over A. And we just said that we know that A, the radius for our major axis is 4. In the problem, they actually flat out told us that the eccentricity was 1/2. So I can replace the E with 1/2. So then the question becomes, how do I solve this equation for C? Well, because that's the only place I can go right now, is first you can multiply both sides by 4. That will get rid of your fraction here. That will get rid of the 4 on the bottom by multiplying by 4. But then be careful, 4 times 1/2 is 2. So what that does is that gives us that C equals 2. Well, that doesn't actually give us the equation of the ellipse. It does help us, though. We need A and B. We've got A and C now. Well, we know that C, being 2, can be plugged into that formula for C squared equals A squared minus B squared. So if we plug in the C of 2 that we just came up with, C squared will be 4. And we already knew that our major axis had a radius of 4. That means A was 4. So we'll have our A squared, which is 4 squared, will be 16. We already had our C squared, which was 2 squared is 4. We're just looking for our B now. Well, first of all, to solve this for B, you're going to subtract 16 from both sides. That gives us a -12, but that's okay because you also have a negative in front of the B squared. So you can divide both sides by a -1, which will make that -12 turn into a +12. We still have to get rid of the squared on the B, so we have to take the square root of both sides of the equation. What's special with the square root of 12 is that it can be reduced by breaking the 12 up into 4 times 3. Remember that you can take the square root of 4. It comes out as a 2. The 3 you can't, so that will stay inside. So let's keep going. So because our major axis was X and it had a radius of 4, we can put a 4 squared, an A squared or 4 squared. A was 4, so that means that 4 squared, your A squared goes on the bottom, which was 16. Now, we just found out that B is equal to 2 square roots of 3. That's actually not what's important. What's important is that actually B squared equals 12. Remember, what goes on the bottom is the minor axis squared, the radius squared, which means I can just go ahead and put in a 12 because that's what's going to go underneath there, your B squared. Now, notice the question is that will anything go inside of the x squared and the y squared? Well, if the vertices were at negative 4, 0, and 4, 0, that means the center, the y-axis of the center here, the y value for the center should also be 0, because when your vertices move and they're on the x-axis, the other axis, the y value, should stay the same. So our center should be at 0 for the y-axis and should be at the center of the other two x values, which are negative 4 and 4. Well, what's at the center of negative 4 and 4 is 0. So that means our center is at 0, 0. So there shouldn't be anything with the x's and there shouldn't be anything with the y's. And remember, with an ellipse, just like before, there should be a plus and it should equal 1. So that's everything. We end up with x squared over 16 plus y squared over 12 equals 1. And that's our final answer for our ellipse based on